again to oxidation state, determination, and calculation. You can see clearly now the board. Okay, this is vlog number 2 of this very beautiful Saturday. Okay, beautiful because I am wearing makalenlen. Shout out Lenlen! Okay, ganon. So, let's do calculate the oxidation state of hydrogen calculate the oxidation state of oxygen and hydrogen peroxide. Okay, now guys, in here, it's not easy because the hydrogen peroxide as this is molecular compound, yes, it's not being emphasized or expressed. So all we have to do is to convert the word formula into chemical formula. So things like this are quite often in examination, in chemistry, topics in science examination. Sometimes they don't put the chemical formula, only word statements. And this is an example, hydrogen peroxide. So you need to have an idea what is a peroxide. Okay, so if we have, let's analyze first. Okay, let's start with the basic determination and identification. It will start with the scrutinization of the terminology or the term. Okay, that's the first thing, so that we can, we can understand well before going further. So hydrogen peroxide. Okay, hydrogen peroxide composed of two words, hydrogen and peroxide, right? So hydrogen is very clear that this is H, right? Then H, you use that H in the balancing of the equation, and we use that H only in the chemical bonding, and we use H2 if we try to react with another element in a chemical reaction. Okay, that's the way how it will be expressed. Because it will just an H without two subscript when you discuss to the topic of chemical bonding, because you are not dealing with a subscript chuba-chuchu. In chemical bonding, you are dealing with the valence electrons or the electrons in the outermost shell. And also, you will also say H during the balancing of chemical equation, right? You will say H atoms in the reactor. You will never say H2, right? So these are the two applications when we will say H only. Okay, now if we say H2, this is hydrogen gas already. So we put H2 if we try to apply this in a chemical reaction. Okay? Like that. So H2 plus O2 blah blah blah. H2 plus chlorine, hydrochloric acid, something like that. Okay? Only hypothetical, but that's the main point. So, okay? Ganun siya. Okay, hydrogen. So H na nakalimutan dali because we are not dealing with chemical reaction. Okay? Now, peroxide. What do you understand by peroxide? So, I will teach you the basic charges of oxygen. We have 3. The first is the original, which is the -2. Okay, the original charge of oxygen, because oxygen have an anion charge, negatively charged ion, or negatively anions. Okay, now -2. Okay, as oxygen, -2. We have also -4. Okay, -2 and -4. Check that also if there's a -4 oxygen. Nakakaloka. You got the point? But I think there's nothing, right? Because, okay, before I put, I think, because 4 is too huge. Okay, sorry for that, guys. Really on the spot kasi yung discussion ko. Okay, so 4 is, it's too huge. I think 4 is for family in the group, so it's not applicable. Okay, so we have only the O3, and the O2, and the peroxide. Okay, so 3 is the maximum, not 4. Sorry for that. So I was shocked. Oh, what's big? Like that. So immediately I correct what I said because I'm listening what I'm talking. Okay, so it's gonna be the corrective action immediately. Okay, my gosh. So here O2 is simply the oxygen gas. Okay, because I put O2 for the purpose of discussion, even though we will not put this in a chemical reaction. Okay, so we have O3. O3 is the ozone. So ozone, O3 is the formula of the outer layer of the sun, which is the ozone. It will become thin, THIN, when there are a lot of amounts of greenhouse gases that causes global warming in our climate change due to the release of various gases into the atmosphere, and then it will be converted to carbon dioxide, usually, something like that, and some of the gases. Okay, we are not sure really what are those gases because it depends on the industries producing those exhaust gases into the atmosphere. But we are really sure technically that that is greenhouse gases. Okay, like that is the carbon dioxide. Okay, carbon dioxide. And then this carbon dioxide will go to the ozone layer of the sun, and this is the sun. Okay, this layer to layer, the ingredient and composition and the chemical composition of that is O3, meaning 3 atoms of oxygen, and that is called ozone. Okay, so ozone will protect the layer of the sun so that all the radiant heat energy will not pass to the living organisms in the planet Earth, because you know that the heat of the sun is very huge. Okay, if there's no ozone layer, then all of us will be melt. Okay, we will melt everything in the planet Earth. Okay, so it's been regulated by the power of our Lord God. Okay, like a magic, that is gonna be the principle of the sun, which is called the Proxima Centauri. So by natural process, the huge heat that will be released in the planet Earth that will be transmitted to the living organisms, including the plants, trees, vegetation, everything. So it will not become not too much hot, or else all of us will be melted. Okay? And aside from that also, there's a regulation of the specific heat capacity of the heat of the sun due to its normal cycle. Okay, because of the, the study of the longitude and latitude relationship to the Earth, the planet Earth. If you remember the topic also, right? The longitude, latitude, the equator, and then the Earth will also revolve, something like that, and rotate as it moves in the axis or in the orbit in the universe. So there's also a reason for that. So there's no constant. If the planet Earth is constant, is not moving, okay, and there's the heat of the sun, the Earth will be melted. Okay, that's also another factor. Okay? So, continuously moving, okay, in the orbit of the axis, it will be a rotational movement and, rotate, and then revolve also at the same time. 2. Okay, and also the specific capacity will be regulated also, not direct. And then the third reason, also, because of the ozone layer of the sun that will protect, okay, the radiant heat light of the sun. Okay, so that is called ozone. Okay, O3. So remember this, most of the times will come out this in the board examination in the future like this. Okay, O2 negative 2 is very special. This is now called peroxide. And then you will also wonder, so Sotero, peroxide, why peroxide that is only negative 2? If we can remember also in prefixes, right, or in organic chemistry, negative 2 is pero is 4, right? For example, we have, sorry for that. I'll just connect the basic concept. If I discuss now, I will connect to what I have in my mind, that it is length, okay? So we have, for example, perchloride, perchlorate, permanganate. So what we have in mind is the 4, something, because per is something 4, okay? Or tetra, something like that, okay? For example, tetrachloride, Cl4, like that, right? So now I say 4 dapat. But why peroxide hydrogen is negative 2? And then 2 ang subscript. So this is an exemption. Okay? You get the point? So science is like this. We cannot apply the rules in everything. There's also an example. And we must be clever and smart enough, and we will not be mixed up. Something like that. So we should also, try to analyze very well that there's an exemption, just like a law. Okay, a republic act or a law, there's always an exemption for that. Okay, the same is in science also. Okay, so peroxide is positive 2, subscript negative 2, blah blah blah, so and so. Okay, I will put here the peroxide. What time now? Oh my gosh. So O2 negative 2 and H positive 1 because hydrogen peroxide. Okay, when we combine this in a chemical reaction, take note. This H will become H2, as I told you. So it will become now H2O2. Okay? Like that. H2O2. Now, this coming from the crisscross application or theory in chemistry also. The crisscross, theory is not applicable only in algebra. That's also applicable in chemistry, especially when we transpose both charges in an element constituent in the compound. Because you need to crisscross that one, transferring one over the other so that it will become cancelled and it will become zero, something like that, or else there will be no reaction if it will not become neutral. Okay? All compounds are neutral. Okay? All compounds are neutral, but we will never say neutral something like that. It's understood already as a concept. Because it's also, ironic or funny to always say neutral, hydrochloric acid, neutral, not good, right? So we eliminate that term neutral, but it's understood really that all compounds are neutral because there's no charge in the uppermost. Okay? Like that. Unless that is a polyatomic ion. Okay? That there's a negative one. Or negative 2, but 2. Okay? Now, so this is hydrogen peroxide. Now let's prove this by chemical bonding first. Okay, chemical bonding. So hydrogen, diba? Oxygen, like this. Oxygen has 6 electrons. Ako lang ginigil para masabtan dyan na to why we can come up to H2O2 because that is our question here. What is the, the oxidation number, of hydrogen in hydrogen peroxide, something like that. Okay? Now, 6, tank. Share ang hydrogen to oxygen. Take note, guys, hydrogen is electropositive, loses 1 electron and give to oxygen. Oxygen will never give back to hydrogen. So this is only transfer of electron. Remember, ionic bonding is only transfer of electron, not sharing. Why? Because the electronegative partner, which is a nonmetal, always have so many valence electrons in the outermost shell. Okay? And this electropositive hydrogen don't need extra electron. Okay? Or else he will be also negative. Blah, blah, blah. And by theory, hydrogen is not electronegative. It is electropositive always. And it's not always also, practical to always say all metals as electropositive always. It's understood already by theory and concept that all metals are electropositive. They are ready to give their electrons and losses and give to others, especially the non-metals. Okay? Like that. So these are really the basics. Know the basics and bingo. Okay, you can get higher scores in the examination in the future. Okay, going back to the discussion. Okay, now we have 1 electron has been shared to oxygen. So count that one. So this hydrogen now will become charged because there's a bonding. Okay, if there's a bonding, the impact or the consequence or the result, each elemental constituent will be charged. Okay, will be charged. So it could either be positively charged and negatively charged. So in the reactant, there's no charge to there. It's still a neutral, blah, blah, blah. Okay, see, hydrogen is neutral. There's no charge yet, right? Being expressed there because we don't put 1, blah, 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 like this. So, like this. And oxygen also, we don't put blah, 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 that is neutral. When it become charged, bonding, that's why that's a charge na talaga siya. So it will become now, okay, like this. Nakakaloka na, di ba? So H, I-transfer mo 3 it will become H positive na. Okay? Because it is positively charged na siya talaga. From neutral. Okay? Neutrality. When you speak of neutrality, guys, it will have always a mass of 0. And it is called a neutron. Okay? Neutron means neutral. Okay? Like that. That's why it starts with letter N-E-U. Okay? So that's only sets the difference between a neutron and a proton. That's why usually magkapareho sila. Okay? But not all the time. For the reason that neutron and proton are inside the nucleus. We have related mass in kilograms, which is 1.67 times 10 to the negative 27 kilogram. Okay? Nearly almost the same. Okay? Only the point something. So that's why magkuyog sila Fermi inside the nucleus. Okay? That's why when this H will be charged, it will become a proton, which is H plus. Because it started from a neutron. It's impossible for the neutron to become electron in the charge, impact, or consequence. You get the point? So it will never be happening unless it is a non-metal that has a negative charge. Okay, going back. Okay, so H positive plus oxygen. Now your oxygen, since you're receiving the electron of hydrogen which is 1, it will become 7 na. 1, 2, 3, 4, 5, 6, 7. Because you received the 1 electron coming from the hydrogen. And now, you will put negative na 1 at the top of oxygen. So the oxygen now become negatively charged. Okay? Anion. Okay? That's the thing. So this is now an ionic bonding. Okay? Nakuha ninyo guys? Okay? Kaya nihatag raman siya, ni-transfer raman siya ng electrons. Okay? Ganon siya. Nakaloka. Okay? So going back na ta. Ang atong de-emphasize here, para masagta na ito. No? Okay, now we go back to how many oxygen or oxidation number of hydrogen peroxide. Now, we can memorize now that hydrogen peroxide is H2O2. Okay? So we should put that in our brain cells so that until 60 years old, 70 years old, before we die, until our last breath, we remember that hydrogen peroxide is H2O2. Okay? Like that. Okay. So H2O2. So H2O2 is coming from the reaction of H2 plus oxygen gas to produce H2O2, right? But we are not dealing with a chemical reaction, we're dealing on oxidation number talaga siya. So here, we focus on H2O2. So, we are asking for the oxidation number. Sorry guys, so many, things in my brain cells. Okay, so H positive 1 and oxygen negative 2, right? So, like that, so we will find now. Okay, so 2 times 1 plus 2 times X is equals to 0. As I told you, all compound has a charge of 0 because that is neutral, coming from the word neutron. Okay? Get the point? So for the value of X, 2X is equals to negative 2, X is equals to negative 2 divided by 2, X is equals to negative 1. Take note. The oxidation number and the oxidation state, guys, this is the common mistakes of students, also including me when I was in first year college. Okay? Take note, the oxidation number and the oxidation state is only negative 1 for oxygen and hydrogen peroxide, but take note, the charge originally is negative 2. Meaning to say, the charge is not the same as the oxidation number and the oxidation state. This is the gray part also, because majority will say the charge is just also equal to the oxidation number, oxidation state. Sometimes it will be equal, but it is not really all the time. That's why you will not memorize in that way, right? Because it's not all the time will be equal. So you have to follow this pattern, such like this, so that you will get perfect answer, especially topic of the determination of oxidation number and oxidation state. So again, oxidation state and oxidation number. So oxidation state is just equal to oxidation number, which is why I always emphasize that because it can be used interchangeably, the terminology. Sometimes I can use oxidation state only, sometimes I can also use oxidation number. It's just the same. Okay? Ang lubugan yung utok is just the same. For the purpose of this discussion, only I use the two. Okay? So we have here, so X is equal to -1, oxidation number is not equal to the charge of oxygen in the hydrogen peroxide, which is -2. See? Okay. So our answer is -1 in determination of how many oxidation numbers or oxidation state in hydrogen peroxide. It doesn't connect to the chemical reaction and it doesn't connect also to the chemical bonding. Okay? Like that. Okay. So that's the rule in determining the oxidation number. Okay, any questions so far for hydrogen peroxide? Okay, and by the way, class, to add a little bit of information, hydrogen peroxide is considered as an antiseptic, disinfectant, and antimicrobial agent to treat the wounds, healing the wounds, and for the cuts. Cuts, CUT is if there's a blood, something like that, and also used also in cleaning different stains in our clothes. It's usually combined as a raw material in your soap, powder soap, detergent. There's a little bit of hydrogen peroxide mixed in there. Of course, they will never say that there is hydrogen peroxide, only the raw materials, because there's a lot of composition before it will become a detergent. Okay? Like that. And this belongs to the surfactant family. Okay? Surfactant meaning surfaces, because it will remove the stains, something like that, the oily particles. So that's the purpose of majority of the surfactants. So meaning to say, so detergent belong to the surfactants, something like that. From the word surface. Okay, surface of the clothes, surface of the tiles, surface of the sink, surface of the wall. So that's what it means by surfactants. That's why it's called cleaning surfaces. Okay, this hydrogen peroxide. You get the point? Not only that also, this can be used also in the breaking up of protein. Okay, into hydrogen and oxygen as free radicals inside our body. Biochemistry na siya application. So, also, hydrogen peroxide or agua oxidada is very, very, very important. That's why if this ink is a permanent ink, I will write here, this will be removed by hydrogen peroxide because that is cleaning surfaces. You get the point? Okay, I'm not really that sure with alcohol. Okay, but I'm sure acetone can remove the ink. Let's try by actual observation if it's really true. It's really true because the only way to prove is to have an experimentation, actual experimentation. But this is only based in theory because it's cleaning surfaces, right? And removing stains. Okay, if it can remove the stains, how much more the ink? You get the point? Ink is made of dye, D-Y-E. And then that is a coloring, and coloring will just disappear if you will just to put in a solution of water. Most of them will just slowly and gradually eliminate it because there's a reaction between the dye and the water in aqueous solution. Ganon. So chemical reaction pa rin when you do the washing. Okay? So the washing of clothes really performs the chemical reaction, the reaction between the stain and the water. Okay, the reaction of the ingredients of the detergent and the water. And I don't have to mention and specify that one by one, there's a lot. Okay, something like that. Still, you are doing chemical reaction. That it's not a physical change, but chemical reaction takes place. Okay, tingnan naman, solid converted to liquid. And then the bubble will go to the atmosphere. Bubble. Okay, for example, when you do the manual washing in the direct sunlight, there's a bubble, right? So it will become a gas from solid, liquid combination, then release a gas. But in case of the washing machine, you will never see that, or you will never see that in your eyes. But actually, it's also disappearing. Okay, because you cannot see the gas that will vaporize during the drying process. Drying. Okay, after you wet, you rinse, you wash, and then you spin, and then the last part will be drying. It's in the drying process that the wet or the moisture will be evaporating. So again, still the same principle. So solid, the detergent, okay, plus okay, the water, which is a liquid, then burden, the last part, through drying, then the moisture will evaporate to the atmosphere. So, chemical reaction takes place, or chemical change takes place, not physical change. Okay, ganon. So it's always like that, physical change, chemical change all the time in chemistry. Okay, like that, and a change would mean a chemical bonding and a chemical reaction or a composition of the phases of matter. Okay, ganon siya. Not necessarily all the time that the forms or the phases will change or alters or deform, or meaning it will be broken down through decomposition. Sorry guys. Nakakaloka. Okay? Nabuang na ako. Okay, sige. Thank you so much for watching this short vlog. Okay, you can comment, like, and share to anybody else, especially our, the senior high school chemistry students or chemistry students, blah, 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 so and so. Okay, and you can also like, and you can share. So that's really, you can click the notification bell for some of us after 7. Singer, bye-bye, God bless! Okay, need 25 minutes na ako, guys. Sorry. Na-exceed ko sa limit. Shut up! Diba?